All right. Let me see. Hopefully you can hear me all right. Woke up not long ago. Oop. I am forgetting. Not bad, good accuracy. X. Ooh. Yeah, not bad. Could be better still. One more. Three. 2. 0, comma, space, 1, 2, 2, comma, space, 3. Make no mistakes. 4, comma, space, 5. For int I is 0, I is less than 3, I plus plus. For int j equals 0, j is less than 2, j plus plus. Element at x I j yeah, very much flatlining. I'm going to do one Leetcode from Leetcode. But the thing is, I'm going to have to do the one that I haven't done in a while. Should I? I mean, I can maybe just have a quick reviser on what these look like, right? And I'll do a new one. I think that might be smarter. Alright, so lowest common ancestor in a binary tree. Let me see. Lowest common ancestor 3, 5. The lowest common ancestor is 5. Lowest common ancestor of 3 and 4 is 3. Lowest common ancestor of 3 and 8 is 5. Alright. So then how you think about this question is recursively DFS, essentially. Okay, so let's just run this through. So while true, if the root value 5 is less than the p-value 3, that's not the case, and the root value is less than the q-value, well, it is, but that's equal to right. Okay, but that's not the case. That's not the case either. So we just return the root. However, if we got 3 and 4, well, is the root value less than the p-value and the root value is less than the q-value? Yes, it is. Well, actually, it's the other way around. These, then it goes to the root left. From the root left, 3. You look if the root value is less than the p-value. No, it isn't, because it's 3 is less than 3, which is not true. And is it greater? So you would return the root. Wow. I see, and that is pretty smart now. Sure. Our level order traversal of binary tree. Given a binary tree root 1, 2, 3, 4, 5, 6, 7. Return the level order traversal of it as a nested list, where each sublist contains the value of nodes at particular levels of the tree from left to right. So this would still be an O of n operation. Be that difficult? My belief is do a breadth first search. And the question is, how do you do a breadth first search? All right, you're going to use a priority queue, probably. And the methods used for a priority queue, that's something that so let me go to Obsidian for a second. Okay. Mad. What do I need? I need boilerplate code. To think about it. Breadth first search. If I take a look and try and find nope, I need a search by tag, to be honest. Binary tree, BFS, BFS. BFS, okay, using BFS, use a queue with pop left and append. Pop left. This is still a list then. Don't need anything fancy, no? My understanding is you don't even need a priority queue function. You can just have like queue. Yeah, I can't type here. Okay. Queue equals an empty list while what? While queue is not equal to an empty list. Alright, it makes sense this way when I write it. You'd want to root. You'd want to what? Q.popLeft to get some node. Am I convinced? Top left and append, yeah, it's going to be a queue, so that is a queue. And might need to even keep track of, say, you know, maybe like a depth. So a depth of 0 here is what we're starting off with. Perhaps. Depth. Okay. With the node and the depth. Oof. Put it in a hash table. Yeah, I can see myself putting it in a hash table. You'd have to return a O of n space complexity anyway, so I don't see why not. Right? I don't see why not just do that. Sorry, table depth dot append, and then we're just going to write the node val, and And at the very top of this, from collections import default dict. And we change this to default dict of a list. And then what? So you have a table with the depth, and you append the node's value to that depth. What do you do next? While q is not 0, you go to q.append as well, some new value. Well, there has to probably be node.left and depth plus equal to 1. Or I should say depth plus 1. And you would do the same thing for the right side. And is this not... No, it isn't. This is this is depth first search. This is good. I really don't need to do it in depth first search then, you know? It's probably not necessary, but I did it anyway. And that would do it. But then we want to return, not return. For each value in the table. O of n, yeah, I guess it doesn't matter either. So because the best is O of 10 anyway. So table values. Table of values. I think that would work because, yeah, I'm using a hash table here. Issues should prevail, should exist. List object has no prop left. Okay, so you do need from, it's probably like from collections import p, man. Damn it, I just closed the tab unintentionally. It's called pop left. Yo, hello Zohype. Where is the face cam? It's actually charging because I haven't actually used it for a while. Long time no see indeed. Thank you for joining. DQ. Yeah, okay, it is DQ. I probably gotta write that down. Did you complete the course I told you? Nah, I didn't have time. Ain't happening. Oh, it's still a list, right? Right. Is it? Possibly I've been doing this wrong, using DQ wrong here. Bro, all on YouTube feed get is that coding is dead. Your YouTube feed? I haven't been seeing that. Why? Because of AI? So they say. I hope that's fine. Oh well, I did that wrong. Nah man, don't believe that shit. Watch the Primogen, he'll tell you everything about it. Really not that sad, I would say. Could be worse. And even if coding is dead, you just gotta become a better programmer. Man, a bro just made 10 videos on the same topic and they got 100k plus views, yeah. Well, that's what, no, the whole reason people make these videos is it's because they get views. So it's not because other people agree with them necessarily, but it's because it's hooked people into the topic. And honestly, it's probably more fear mongering than I would like. So I don't even contribute or think about that stuff. Not that I'm blissfully unaware, but something that I think doesn't need my attention. Okay, I think I realized where my issue is. Nah man, what? QDQ root node equals q.popleft. Am I spelling pop left incorrectly? Pop left. dq 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 dq. Oh, I'm forgetting also that I'm forgetting that I should say if node left, right? That's one thing. If node right, then you add that to the depth and you add it to the table. You do here. And this is still, how am I doing this wrong here actually? From collections, import default dict DQ. Okay, why can't I, let me just search this up. Why not? I'll just search it up. Search up the answer. So collections has no attribute top left. The one guy who followed for a long time, he's really good at coding. He tweeted the coding is officially finished, was nice while it lasted, but it's time for me to start switching careers. This got me into thinking for real. Hey, even if you think about it, that's natural. That's a normal thing to have, right? Second guessing yourself into things. But with, I guess, you look up to this guy and, when he says that, it makes you worried. I think then maybe it's also about just being confident in your choice, So I think in my case, I'm pretty confident in going down coding route in my career. And, I've invested in this keyboard. I literally do coding videos. I'm pretty invested, I think because my investment in it, I'm pretty solidified in my, I guess, understanding of the tech landscape. Not necessarily tech landscape, but how I fit into it. Even if AI takes jobs, it really can't take that many. And if there are jobs that are taken by AI, who makes the AI, firstly? Right? Programmers. Programmers make AI. I think we're the least likely to lose our jobs. It just means we gotta be better programmers, make code that's better than what an AI standard is. If anything, the AI standard just increases our standards of programming. Oh, hello, Biodecay. Recession is going to end sooner or later, even if not, I'll just go get a job as a tradie because that's always going to be in demand. Yeah, man. I don't think, I don't think I can get into the trades. I don't think I have the right connections to, but definitely, having options besides just one career path is always good. And for me, at least, I think coding in general has a pretty large spectrum anyway, so there's always something to work on. It could even be like no code. For some time I was coding in no code, as antithetical that sounds. Am I really just doing this wrong? DQ, top left. What? I'm so confused. I mean, these Stack Overflow posts are more brain dead than if I were to just try and figure it out here. I suppose I only add the node val. No, that's not even the right place to put stuff. Q, DQ'd. Man, what's wrong here? Q.pop left. Collections DQ object has no attribute pop left. Like, how in the world does it not? Man, Reddit arguments are crazy. Pop left, man. I just want to pop left. Let me just spin up a quick example, right? Oh my god, am I that munted? Sure, for sure. I am just that. Surely, like, what am I? It is just a lowercase l. This whole time, man. This whole time. Can't believe it. So, call this correctly as to what it actually is. Top left of, so use a Q, which is going to be from collections import DQ, and then, you know, probably also need to make mention of how to make the queue. I suppose it's okay to just do something like this here. Q equals DQ with some list inside. hello world. And then you can pop left and append. Okay, we're good. Man. Okay, fine. Index error popped from an empty queue. Interesting. Interesting. The output was this, but expected of list int. Are valid. I guess you can just turn this to a list. It doesn't work for all the cases, right? Okay. Alright, if you have nothing in there, well, yeah. If root, then you would do this. Well, if not root, then you would return none. Oh, wait, is it none? No, you return just an empty list. There's something else that's going to fail me? Alright, we're fine. Breath first search. Alright, I'm going to eat in just a quick moment. I could finish watching this and then I'll eat. I'll come back. I'll watch this when I'm eating. Yeah, let's do that. Alright, I'll be right back, guys. Just gonna eat, take a break, and then I'll get to doing some other study. Apart from Leetcode. Because there's still quite a lot of other stuff to do, not gonna lie. Yeah. Alright, so let's see. I will need to. Alright. See you guys. I don't see why the solution has to use a for loop at all, to be honest. Let's try and understand it, right? Node equals q.pop left, value append, node left, node right, result.append value. I suppose in this case you just want to make a for loop so you can not use a hash table at all. There's really no need if you do make use of that hash table. Alright, let me see this video.
Level order traversal. It's basically just like it sounds. So we're given a binary tree and we want to return the level order traversal of its nodes. So basically, I'm going from left to right. So the second level, we'll see 9 and 20, right? We want to add that to a separate list. And lastly, we'll get to the third level. Going from left to right, we have a 15 and then a 7. We're going to add that to the third list. And so we've traversed the list in level order traversal, and each of these sublists are going to be put together into a single list, and then that's going to be our result. So that's what we want to do. We know that that's pretty straightforward. So the only question now is, do you know an algorithm that can do that can traverse it level order? And if you don't, the algorithm is breadth first search. So we want to run breadth first search on our tree and then add the values into lists. And the second thing to notice is, do you know how to implement this breadth first search? So we need to know this is the algorithm to use, and now we need to know how to implement it, and let me show you how to do that. So we have a tree and we want to run a pretty standard algorithm on that tree called breadth first search. And you might know how to already implement this algorithm. You need a queue data structure because we're going to be inserting elements to the right, meaning we're going to, insert an element here, 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 right? We're going to be adding elements to the right portion, and we're going to be popping elements from the left portion. So as soon as so basically we're following first in, first out, right? The first element that gets inserted over here is going to be the first element that gets removed, right? So that's the order we're going to be doing things in. So the first thing we're going to do is take the first element, 3, and add it to our queue. This is basically to initialize the queue, right? And we know we're creating sublists, right? So what we're going to do now is see that, okay, count how many elements are in our queue initially, right? There's 1 element in our queue. So we're going to basically remove 1 element from our queue. We're going to see, okay, the 3 is in the queue. Now let's get rid of the 3 and add it to a sublist, right? Now the queue is empty. So we know that this sublist is complete. And what that tells us is basically we went through the entire first level, right? That's what we're trying to do. We're going through every level. We know that the first level only had 1 element in it, so now we're done. But when we pop that 3, we need to add its children, right? It has 2 children. It has a child 9 and a child 20. So we're going to add those children to our queue. And we're going to do it from left to right because that's important, right? We're doing this from left to right. So we're going to add a 9, then we're going to add a 20. Okay, so now we want to go through the second level of the tree, right? So we're going to have a sublist for the second level. Clearly, we have 2 elements in our queue. So we're going to basically pop these 2 elements from our queue from left to right. So the left is 9. We're going to pop 9 from the queue, add it to the sublist. So 9 is added to the sublist. And notice how 9 did not have any children, right? So we don't have to add any children for 9 into our queue. So next, we still, remember we had 2 elements we were trying to remove. We have 2 elements in this level. So let's now pop 20. So we can add 20 to our sublist, right? So now Clearly, this level is complete. We added both nodes in the order 9 and 20 to a sublist. But notice 20 had a couple children. It had 15 and 7. So as we remove 20 from our queue, we're adding its children to the queue for the next level, right? Because we know we want to keep going down a level. So when we get here, the values will already be added to our queue. So 15 and 7 are added to our queue. We're done with the second level. Now time to go to the third level. We see that there's 2 nodes, 2 values in our queue. So we're going to pop both of these values. First, we pop 15, add it to the sublist for the third level. And then we pop 7, add it to the sublist for the third level. Neither of these nodes had any children, so now we're done. We know we're done because our queue is now empty, right? There's nothing left in our queue. So we created a sublist for every single level, and as the question wanted us to do, we're going to package all 3 of these sublists into one list and then return that as our result. So we're really just doing a breadth first search algorithm with a queue on this binary search tree. And since we're doing it like that, the time complexity is going to be O of n. We're only visiting every single node a single time. The memory complexity is also O of n because our queue at any given point in time, our queue could have up to n divided by 2 elements in it, because the biggest level of a tree could be n divided by 2. That's how trees work, binary trees at least. And so we know that n divided by 2 can be rounded to big O of n. So the memory complexity is big O of n with breadth first search. So with that being said, let's jump into the code. So first, let's initialize an array for the result. And we also, remember, want to have a queue. So in Python, we can do that with collections.dec. This will give us a queue, and the first value we want to initialize this queue with is the root node that we're given. So with that, we can start running the breadth first search, and we're going to run breadth first search while our queue is non-empty, remember? And since the queue is non-empty, we're going to get the length of the queue, right? So we're going to get the number of nodes or values that are in this queue currently, and we're going to loop through every single one of those values. This queue length is basically ensuring that we iterate through one level at a time. We're going through one level at a time. And with those nodes from that level, we're going to be adding them to its own list, right? And then we're going to add that list to the result list. So I'm going to loop through every value in this queue currently. So for queue length, I'm going to pop nodes from the left of the queue, right? First in, first out. And it's technically possible that the node could be null, so I'm going to have a check to make sure it's not null. Then we're going to take the node value and append it to the list level. And don't forget, this is also important, that to our queue, we make sure to add the children of this node. So node.left and node.right. Technically, these could be null, but that's why we have this if statement. So then when the next loop comes around, right, we come around to the next iteration of the while loop, it'll make sure to check that these nodes are non-null before adding them to its own level list. Okay, so now we have the loop in place that's going to iterate through every node of a single level. After we've done that entire level, what we're going to do is take our result and make sure we add every single level to that result, right? And then we're going to keep running this outside while loop, the outer while loop, until there are no nodes left in our queue. That's how we know we've gone through every single level, added it to the result, and then at the end we can finally return the result. And one last thing we want to do is make sure that if we're adding a level to the result, we want to make sure that level is non-empty, because we know technically our queue could have null nodes. We're not adding null nodes to the level list, so we want to make sure that level is non-empty if we're adding it to the result. We can run the code and see that it does work, and it is pretty efficient. This is a breadth first.
Yeah, that's fine. I'm fine. All right, study. I'm gonna just do one monkey type again. Bow walnuts, hello, hello. How are you, mate? Yeah, not bad. Finished assignments, so I'm able to stream more while I study. Except, you know, when I was doing my assignments, I didn't want to like share it publicly, so that's why I didn't. But now I'm not doing assignments at the moment. So hopefully this weekend I can just like, well, today's Monday anyway, but hopefully assignments don't come out until Friday or something, so I can stream more. But yeah, the assignments that I've had, they were all pretty good. I feel it did take a lot of time to write. That's why I've been away. Yeah, you've got a bunch of assignments too, right? I wouldn't disagree. God damn. .NET and React. Interesting. This is in. Is this like a course you're taking at uni? Because if so, that's kind of based. You need to do that. Oh, it's at TAFE. Okay, makes sense, right? Okay, that makes sense. Because you, in the sense that you're doing things more practically, which is good. Hold on. It's less theory, yeah. Makes sense. Outside of my course, I'm like obsessed with sysadmin stuff at the moment. I think I'll probably head in that direction. Hell yeah. I mean, what type of sysadmin stuff? You got a home server and stuff? If so, that'd be sick. Because I do too. DevOps, sysadmin, and just pure hacking. Damn. Surely you got Kali Linux set up now. You know what I mean? You know what I'm saying? Like, get Kali Linux. Yeah, I have virtual server, but I'm planning a home server. Epic. Do you know what type of hardware you're gonna get actually? Because if I were to suggest, I'd just say get a Raspberry Pi to start off. Damn, that was not bad. I'm going to get a new desktop and deck it out with AMD and flip my desktop into a server. Okay. Okay, nice, yeah. Alright, fair enough. Yeah, I got myself 2 different servers at home actually. One is a Raspberry Pi, another is like a NAS, network access storage, or network accessible storage. I don't know exactly the acronym, but yeah, I have one of those. And actually the NAS device runs okay, except when there's a lot of Docker files on it. So there's a little bit, it's okay at running Docker. It's because it's got a worse CPU and no GPU at all. And it's only meant to be a NAS anyway. Arguably, my Raspberry Pi works better than this computer. And I think it's because of the CPU. I think the CPU is not good enough. Lol, true. Nah. Anyway, I have class. I'll chat later. All good. All good. Alright, 40 words per minute. I'm kind of good. Alright. You have class, I have study. Now the best way to learn for this, I think, is so I'm only going to be reading. I need to write down questions. So I'm going to put this on the side and then just write questions here. So what does 3DES prevent? Meet in the middle attacks. What is the consequence of using electronic code block mode? The benefit. Crypto C1 will be the same as C2, which means P1 and P2 are same. Or what is the consequence? Damn, okay, sure. Let me see this. ECB. Right, you use a single key that you encrypt, but with what? Not necessarily XORed or anything. So, okay. Still need to fully understand that. Why is the initialization vector needed in cipher blockchaining? Well, cipher blockchaining needs it in order to commence the functionality that it's trying to achieve, which is use the previous ciphertext to encrypt the next plaintext. or mainly just to XOR main next plain text. So if I have a look at what that, so you use the initialization vector to XOR before encrypting, You do this continuously, and then when you decrypt, use the key and then the initialization vector XOR to decrypt. And this is how cipher blockchaining works, which is pretty much what currently works for everything. Cool. So that's fine. However, it's a matter of reading through this. So these slides are taken directly from chapter 7. So cipher block mode, double encryption. Let me zoom out a bit maybe. Okay, so meet in the middle attack. The use of double DES results in mapping that is not equivalent to a single DES encryption. Sure. The meet in the middle attack algorithm will attack this scheme and does not depend on any particular property of DES, but will work against any block encryption cipher. Will work against any block encryption cipher. Okay, meet in the middle attack works on any block encryption, which is interesting because I don't know how that works. Alright, so if I copy link, tab, Control V, tab, Shift tab. Okay. Triple. Okay, so here's the thing. We never talk about meet in the middle again. And attack. A meet in the middle attack, so is a known plain text attack. Is a generic space-time trade-off cryptographic attack against encryption schemes that rely on performing multiple encryption operations in sequence. Meet in the middle attack is the primary reason why double DES is not used and why triple DES can be brute forced by an attacker with 2 to the 56 space and 212 operations. When trying to improve the security of a block cipher, a tempting idea is to encrypt the data several times using multiple keys. One might think this doubles or even n-tuples the security of the multiple encryption scheme, depending on the number of times the data is encrypted. Because an exhaustive search of all possible combinations of keys, simple brute force would take 2 to the power of n times k attempts if the data is encrypted with k-bit keys n times. The meet in the middle is a generic attack which weakens the security benefit of multiple encryption using multiple encryptions by storing immediate values from the encryptions or decryptions and use those to improve the time required to brute force the decryption keys. Is this not like dynamic programming? Why does this feel like dynamic programming? Okay, this makes a meet in the middle attack generic space time trade-off cryptographic attack. The meet in the middle attack attempts to find keys by using both the range and domain composition of several functions or block ciphers, such that the forward mapping through the first functions is the same as the backward mapping inverse image through the last functions, quite literally meeting in the middle of the composition function. I see. For example, about double DES, although double DES encrypts the data with 2 different 56-bit keys, The double DS can be broken with 2 to the 57 encryption and decryption operations. The multi-dimensional meet-in-the-middle attack uses a combination of several simultaneous meet-in-the-middle attacks like described above, where the meet happens in multiple positions in the composed function. Okay, Diffie and Hellman first proposed the meet-in-the-middle attack on a hypothetical expansion of the block cipher. Their attack uses space-time trade-off to break the doubled encryption scheme in only twice the time needed to break the single encryption scheme. Investigated the multi-dimensional and presented new attacks on the block ciphers. Hummingbird 2, damn. Alright, so meet in the middle. One-dimensional. This might be pretty good. I mean, here's the other thing, right? Alright, let's just have a quick look at just maybe this first section, and then, you know, the textbook also has probably some more information there. Assuming someone wants to attack an encryption scheme, the following characteristics for a given plaintext and ciphertext. So you got encryption, encryption P, decryption, decryption C. So the first thing that I also want to, another thing that I want to understand is triple DES. Okay, DES is another thing that I need to fully understand, right? I guess this is a DES activity sheet that I spent my time realizing. Feastel. Okay, so we're talking about Feastel. Feastel, what is an example of a Feastel cipher? DES. An example of a Feastel cipher. Is not Feastel, AES. An iterative cipher that is not. Diffusion and confusion principles. Tough, man. Data encryption standard. A Feastel cipher with a block size of 64 bits and a key size of 56 bits. Number is specified with 64 bits containing 8 bits of parity. And the number of rounds is 16. And strengthening DSX. Apart from 56, choose a new 64-bit key. This method increases effective key length, where T is a quantity related to adversary's cryptanalytic assumptions. T is the quantity related to adversary's cryptanalytic assumptions, where the adversary is able to collect 2 to the T matching input-output pairs. read the textbook for more information on DES. Yeah, the fact of the matter is, this is pretty intense, no? Okay, feasible cipher structure. Okay, a product cipher combines two or more transformations so that the resulting cipher is more secure than the individual components by making use of confusion and diffusion principles. An iterated block cipher. Feastal cipher is an example of an iterated block cipher. Sure. Alright, but feastal structure. That was the drawing that he made. And that is another drawing. Another drawing. Okay. 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 So I guess this is the interesting part. All right, well, man, I guess, this is something that I gotta write down. Alright, I only kind of need a high level understanding of the meat in the middle attack. Triple DES. Hey, hey Alan. Prepping for an AWS interview. I feel so dumb right now. You mean Amazon? Or is it specifically AWS? Hey, it's okay. I think everyone feels dumb, you know? Ah, yes. Software developer 1. I don't know what 1 actually even refers to be honest. But good on you. Let's see how it goes, right? I think my brain is not built for Leetcode. Nah, don't think that, man. I mean, I don't think my brain is built for Leetcode either. Right. I think I understand what you mean. Leetcode's just something we ought to do if we want to get to big tech. I've been spending all day trying to understand the combination problems. It's so frustrating. Interesting. Combinations. As in, like, literally combinations and permutations combinations. I see. I don't think I've come across any specific Leetcode combination problems, actually. Backtracking recursion, but I see. Yeah, I'm not up to there yet. Still on binary search. So you're ahead of me anyway. Feels like you would know more than me already, to be honest, in terms of Leetcode. Two-key triple encryption with candidate pairs of keys. Do I understand this? Not really. I think I need to read up on the textbook there. Oh, this is annoying. Read up on the actual textbook here. Does mean I should try and put the textbook into Obsidian. I don't need to look back twice. Try and find this. So William Stallings. No. Okay. Gonna be probably in its own folder. Okay. And we're probably looking at chapter 7. Let's see. Chapter 7. Electronic code block. Multiple encryption and DES. Okay, I'm gonna have to understand this. Actually, do I need to understand it? Do I? Practically. Really? I mean, I'm kind of interested. Copy link to annotation. I can do that, can I? Interesting. So that was DES. I suppose I could put it here. Yo, that's kind of mad, to be honest. I'm not gonna lie, that is mad. Sick of Obsidian. As in, that's sick of Obsidian to be able to do that. Okay. I don't understand this figure. So let me search and try and see it. Known plain text attack on triple DES. Okay. Okay. Known plain text attack is outlined in Vino 90. This method is an improvement over the chosen plain text approach. It requires more effort. The attack is based on the observation that if we know A and C, we know A and C, figure 7.1b, we know A and C, okay, sure. So if we know attack is based on the observation that if we know A and C, then the problem reduces to that of an attack on double DES. Of course, the attacker does not know A, even if P and C are known, as long as the two keys are unknown. However, the attacker can choose a potential value of A and then try to find a known P-C pair that produces A. The attack proceeds as follows. Obtain n PC pairs. This is the known plain text. Paste these in a table. Okay, known plain text. Pick an arbitrary value A for A. And create a second table with entries defined in the following fashion. Each of the 2 to the power of 56 possible keys. K1 equals I. Calculates the plain text value Pi such that the decryption of I and A each Pi that matches an entry in table 1 create an entry in table 2 consisting of K1 of the K1 value and the value of B that is produced for the PC pair from table 1, assuming that the value K1 B equals decrypt I and C equals decrypt I and A. The end of the steps, sort table on the value of B. We now have a number of candidate values. And we're in position to each of a value K2 for each of the 256 possible keys. At each step, look up B, J in table 2. There is a match, then the corresponding key plus the value of J candidate values for the unknown key. Why? Because we have found a pair that produces a known PC pair. At each step, look up B. There is a match, then the corresponding key plus the value of J are candidate values for the unknown key. Because we have found a pair of keys I and J that produce a known plain text B and C. Test each candidate pair IJ on a few other plain text ciphertexts. If a pair of keys produce the desired ciphertext, the task is complete. No pair succeeds, repeat step 1 with a new value of A. For a given known PC, the probability of selecting the unique value of A that leads to the success is 1 of 2 to the 64. Thus, given n PC pairs, the probability of success, the single selected value of A is n divided by 2 to the 64. Basic result from probability theory is that the expected number of draws required to draw one red ball out of a bin containing n red balls is n minus n green balls. Is n plus 1 n divided by n minus n plus 1, if the balls are not replaced. So the expected number of values of A that must be tried, large N. Thus the expected number running time of the attack, this order, maybe. Sure. Okay, give me a sec. Gotta go to the gym soon. All right. So what I'm going to do is head to the gym, and I'll be back in about an hour and a half. I think that's good. Try and just spend like less than a minute consolidating my thoughts so that I know what I'm going to do next though. So just going to see how difficult this might be. For sure, this is quite a lot of content, I won't lie. It's not going to be easy to learn well. Okay. I'm going to consolidate my other thoughts here. So when I get home, ideally the thinking is I got to do a lecture, at least. So what I might even do is scrap looking at this for now. And I have to look at least one of these lectures, probably to get me back into it after going to the gym, after having a shower and everything. And then the thought is do as many of the tutorials as possible. Ideally finish them all. So this is a full CS day. Cryptography and security day. Okay. Is there any other alternative to this? Right? What could I possibly do besides this? Besides these things? If I look at my other subjects, I need to add quiz questions, write Obsidian questions, APA tutorial. Oof. Yeah, tutorial questions, quiz questions. You know, this week's content. I think I don't need to be too pedantic either. It's also something I got to think about, to not be too pedantic about understanding. So if there was one thing, if I was to, like, at a broad picture, evaluate what I have the least understanding on, it would be twofold. It would be two things. Cryptography and security, which is what I'm currently studying quite a lot of over the past week, or computer vision, which I'm feeling is going to become more lost if I don't keep on top of it. AI planning for autonomy has been easier to keep track of. I feel like it's needed the least amount of learning because it's quite easy to understand. So I'm going to say, you know, the main objectives are to review CV and are to look at the workshops for CV as well. So those things I need to do as well. Let me think for also another second. Is it week 5 already, or is it week 6? So week 1, week 2, week 3, week 4, week 5. So there's week 5 content all done. So I've got to write notes for week 5. Week 5. Okay. Workshop week 5. This is workshop that I got to do as well. The content is going to just pile up if I don't do some at least today. So I'm gonna try get some done today. In terms of learning of the other subjects, AI planning for autonomy, that can be done on the Tuesday. On the I also probably need to finish watching all the CS lectures so I can be ready for the tutorial on Thursday. Tutorial on Wednesday. And I probably also need, because I'm going to be going to at least one. Oh, wait, but do I go to this computer systems? I mean, no, not computer systems. Cryptography and security. I could go to cryptography and security instead of computer vision. If I do go to cryptography and security, I might be alright. Might be happy. But it might also not be easy to keep track of. It's probably easier to just go to computer vision, and it's probably better if I do go to computer vision. But let me just quickly look at my calendar. Yeah, so I think the plan is I'm 100% going to spend a lot of my day at uni on Wednesday. Doing all 3 different subjects. So I will need to at least, have my understanding in certain aspects. So definitely convolutional neural networks is something I want to write notes on as a foundation, because I feel like over the past 2 weeks that's been pretty foundational to understanding. If I didn't understand it well, then it's kind of actually on me. And then the lecture is not going to matter too much for CS until after, so I might not get that done, which is fine. Which is fine. Okay, I think I've got an idea. There's things that I want to get done today. If I can't get them done today, I'll get them done tomorrow. But for sure, I got to get these lists of things done. Maybe move those to another day. Lecture 1, week 5. Might move that to tomorrow. Might. Alright. I'll come back. I gotta go to the gym, so see you in a bit. Alright, something I gotta do, which is interesting. Give me a second. So currently trying to fix this computer because my parents need help with it. Could be a hardware issue that we're having here. Okay. We might need to just double check that it is in fact the GPU that's the issue. And the only way that I foresee that working is if we try to turn it on. So I'm gonna have to try and turn it on in a sec. So yeah, be right back. Damn, this is annoying. Almost. Nope. Yes? Alright, got rid of the adapter. That was like an additional thing. Press down on this. Okay, I'm able to pull it out, but yeah, it's probably better if I tie this first. Okay, wasn't too hard. Gonna be a little harder actually. Okay, got it. So remember, this is how it goes. Okay. With these two ends, particularly. This is pretty annoying, the wires. Okay. There it is. It's the GPU taken out. The GTX 680. Super old. Super dust filled as well. I'm sure this is the reason. So we know it's a GTX 6080 now. Probably got to figure out what exactly this G4 6080 has as an issue. Is that right? GTX 680 Galaxy. Fan spinning fast. Interesting, so that didn't even help when I switched it up. These guys aren't even giving good results. I'm watching a video now.
Yes. Managed to swap this.
What am I watching?
I do. 99 boarding.
Okay, well, that wasn't fruitful. Well, that is not working. red or green lines on display? Not even true. I don't even have that. Alright, I'm gonna clean this device a little bit. Ooh, getting stuck. NVIDIA GTX 680 Galaxy. The Galaxy GTX 680. Let me type in this exact number. Nope, that doesn't do anything. Maybe the model number? Wait, this is a GTX. There's literally only 2 listings, which is funny as hell. This is so old that it doesn't exist on Google. Wait, it's not that bad, I found it. Release date in 2012, it was literally 12 years ago. Probably the best at the time, to be honest. And well, now it's not even close compared to other ones. Is that the holes that I see? 1, 2, 3, 4, 5. Grill. Yeah, that's exactly it. This is exactly it. I'm sure there's a manual you can use to see the insides. Damn, is there anything I can do actually? I don't even know. I know for a fact it's the GPU. Say without a GPU would be usable. Or 10 times better. how would I even, I don't even know. I honestly think it's gone, man. 12 years? This is probably pretty good. I don't even know how to open the GPU. I guess you unscrew. Okay, so assuming everything else was a heatsink, assuming I can just like unscrew them. None of these actually just fit. Actually, one does. Oh wow, it's springed. Okay. I think I can move this out the way now. Here's the GPU. Ugh. I just got rid of the screws here. Springed screws. Alright. How else am I meant to open? You're telling me I have to open up each and every one of these? We'll make it an experience. I have no idea what to expect inside. There's a whole lot of screws. Wait, are they different? One, two, three, four. Alright, definitely one of them was different. Gotta see what that was. Six. 1, 2, 3, 4, 5, 6. So this one was for the top screw here. Okay, just remember that. Yo. Wait, that's not possible. They put a pentalobe? Let me check my burn. It's like a pentalobe screw. Damn. Gotta search this up. And that's the Torx screw. Wait, does the pentalobe screw also look similar? No, that means I'm done. I'm done for. This is a Torx screw. I don't have a Torx screw. Alright, can't go any further. We're done. Let's put stuff back. Why is there just one screw that's... They just had to make one screw a Torx screw. There was no other option. They really did that on purpose. You know what I'm saying? NVIDIA, goddammit. And I thought NVIDIA was chill.地图。
现在你是这个地方老到全国那边的地图，我怎么换那个地图的？现在老的我会这个怎么？
好，我看一看。
你看你的地图现在是你这里的，这里开始。
就是。
看它那个传感器还有地图显示。
啊，你就可以 pick。
这样就得了是吗？
对。
那个，就看我扫五吧。
扫哪里？
这些那边。
不要搞这边吧，不要搞这里。不要搞这里先。
不要搞这里。
对啊，不要搞这里先。So no good. Can't make it work. We're gonna have to put this back and just see if it works. If it works, it works. If it doesn't, then we're gonna get a new GPU probably. Right, done. Okay. Okay, so it's 100% the GPU problem. That's what we know.
接上看。
Computer's messed up, man. Can't fix it. I'm talking about the different computer that I have at home. I was trying to fix the GPU, can't work. Doesn't work. Am I fine with that now? Maybe. No! Not even the account that I want to sign into. Home chart implementation of image. Ah, I love this. I love this. I love this. Image is so cool, man. Alright. I gotta see task manager. How does my task manager look? performance wise. CPU usage, memory, disk. It's not that bad.
remembered, but it's been a while since everything was okay.
Alright, well, I'm back. Only after quite a lot of troubleshooting, I would say. I did a lot of troubleshooting today, which swifted me away from what I wanted to do. You know, namely, the study for the MST tomorrow. That's okay, because by the end of all that, I am now able to I was able to help my dad install a new GPU into his computer. And that works fine now. I actually didn't realize that you could buy small GPUs that doesn't need external cables to connect to them for it to work. And I didn't know that fact. But it worked pretty smoothly, just connecting it in and making it run. But now I'm missing a monitor. That's why you see this actually. It's because I'm using a single display now to stream. And that means then I have to find some other display to actually, make up for it. The reason why I had to give away my other display, it's not because I had to give it away, but the cable that we used for it, we only had that specific cable used to connect to that specific GPU, to that specific display that Dad has. So yeah, we just had to take the cable from mine, put it onto his. That means now I can rightfully buy another display with a display port rather than one of those weird older ports. So that's all good. I'm happy with that. That means I have to spend money, but that's fine because I probably need a second display anyway, a proper one with a proper standing monitor arm. So I need it. I want it. I need it. I need it, actually. So I'm looking forward to getting it when I do. But right now, the streams go on with a single monitor. We'll see how long I can last with a single monitor. Okay. With all that said, we can get back to work and yeah. I'm just gonna take a 5-minute break and then come back. Man, didn't mean to open VS Code there. Okay. There's something that I gotta do. And that is well, I can't see chat for one. So I'm gonna open up chat. Okay. Cool. So, with all that, I need what exactly? My friend told me of Suncore. What's it called? Internship program. It's a graduate program. Recruitment process. Apply, interview, outcome. It's corporate as it needs to be. Oh wait, I need to click search reply, don't I? Whoa. Wait, how do I even sign up? Nah, I missed it, didn't I? Because it did close today, apparently. No. What's this then, huh? Tech business stream? Students with degrees are encouraged to apply, so that's not even for me. Not this at least. The jobs. Graduate program, technical stream. Business, technical stream. I'm gonna say yes. Yeah, this is good. Sure. Should I? Or a different email? Man, it doesn't matter. Upload resume. Okay, resume. Okay, and back to this. Go to downloads, we have resume. Title, Mr. First name, David Shah. Wow, this is actually gonna out myself quite a bit. Why do you need my home address, bruh? Alright, I'm gonna have to hide this. You can see my keyboard instead, to be honest. Can you see my keyboard? I'm not even gonna... Hello KFC. Apologies for the you can see everything. The reason is I'm currently on one display. Are you available to start full time? Yes. Applying for technical or non-technical? I'm applying for technical. Which technical specialty do you have a preference for? So my preference would be software platform engineering, cybersecurity less so. But what's your preferred location? Melbourne. What technology have you used or have you experience with? Cloud hosting, Python, Java development, a JavaScript UI framework, database for sure, data science, yeah, a little bit, not R actually, but yeah, we'll call it data science. Data modeling, dimensional, data vault, none. iOS or Android mobile, okay, I would like to do that, to be honest though. When did you or expect to graduate? Finish full-time study, not attending a graduation ceremony. I expect to graduate in February, graduating after February 2025. What? I'm not going for... Graduating in 2024 or prior to Jan 2025. What am I thinking? Alright, I'm just gonna say this. Please provide the date you finished. I don't know, 30th November. Uh, 2023. 2023. Australian University, Melbourne University. Please provide the full name of your relevant qualification, either current or completed. What are you studying? Oh, KFC asks, what are you studying? Currently, I'm trying to apply for an application. But yeah, I'm studying. I'm gonna get back to this, which is what's it called? Cryptography and security after this, because I got a test tomorrow. So I just gotta prepare for that. But I promised my friend that I have to finish this application, so I'm doing it right now. Please provide the full name for your relevant qualification, either current or completed. Associate Software Engineer. What is the highest level of qualification you've completed? Oh, we're talking about university. Bachelor of Science, Computing and Software Systems. As part of the qualification, which study areas did you focus on? Science. Information technology. What is the overall weighted average mark? It's 75. And a bit more, but it's alright. What was the most useful source of information in helping you decide to apply? Grad Connection, Uncourt, LinkedIn. You know, make it interesting. Yes. Oh man, I gotta read this. Have you been found guilty of a criminal offense other than a conviction that is spent on the part of? No. Do you have unspent convictions? No. Have you been declared bankrupt in the past? No. At Suncorp, do you identify as a person with disability? No. Do you require any adjustments to participate in the recruitment and selection process? No. No. Okay, so diversity. What gender do you identify with? Male. What is your age? 18 to 24. What is your ancestry? Ancestry. Chinese? Asian? Chinese, Asian? Okay, sure. They really had to specify Asian there. Sure. What is your primary language spoken? English for sure. A little bit of Chinese, you know, Chinese, a little bit. Mandarin. Our organization is committed to increase employment of people. Doing the following information will assist us in planning and improving our recruitment and retention strategies as part of this commitment. Is this even necessary? Prefer not to respond. Well, no, actually. Doesn't matter. What? They want me to upload my resume again. When attaching documents, please ensure file is either MS Word or PDF format. Adobe PDF, like what? What, you think Adobe PDF made the PDF extension? It is. Ah, man, they did. They actually did. I take that back. But you really shouldn't specify Adobe, to be honest. Really necessary. Okay, so resume. Upload a copy of your most recent academic transcript. This is where I'm gonna find what I need, but you guys have to bear with me. I'm gonna go. Okay, done. What is it? So back here, upload. Click this, continue. They really make you double up on questions. Gotta keep my story straight. Oh, there's an online assessment, man. No, man, I can't do the online test right now. Okay, back to home. Even if it takes 40 minutes. Now. Change password. Can I even do that? Create password. Okay, so no, they all use the exact same platform, man. New password. Alright, we'll make a new password, but gotta hide the screen again. Sorry, guys. Okay. What in the world? Nah, what is happening, dog? I'm like kinda lost, not gonna lie. These guys are crazy. Okay, well, that's done. I'm done looking at that for now. By Monday 26th. Wait, what? Yo! Okay, well, final task is to do this. Resume roast. Damn, bro. Some people got scammed by Elon Musk AI fake deepfakes. Some people are full on. Alright, dear students, this is a kind checklist about tomorrow's MST. Make sure you're aware of the MST is held at 11 AM. The location is different from the regular lecture classroom. Remember to bring your student ID card. It is a closed book, paper-based test. You are only allowed to bring your pen and blank draft papers. We'll check them. Yikes. Why don't you just give us draft papers? You know what I mean? You know what I mean? Okay, however, there will be 2 blank pages on the test sheet where you can make drafts. No calculators allowed. Please ensure your final solution is written in pen. Pencil solutions will be marked as 0. They are crazy. They are crazy. They are intense. I won't lie. Full on, man. Okay. Let's have a look at this closely. Okay. So the MST describes the format for the 2024 examination. This document will be updated until closer to the test day. Please arrive 10 minutes before the scheduled start. Right, in Pa Kwong Li Dao exam space. So, you know, the thing is, right, I should make a note of this on my calendar because it's going to be tomorrow. We're talking from 11 a.m. start time. We're going to have to be there. So 11 a.m. start time. We're going to be there by 10:45. Okay? And it goes for 1 hour writing time, 5 minutes reading time. So technically the end time is gonna be 12:05. Nope, not all day. And we're calling this MST, CSMST. Location at, wow, this is, I don't want to type this in, man. Okay. Hey, yo. Got some issues. Okay. Here we go. Alright, I added the space, but I also now need to copy and paste this into the browser so I know exactly where this place is. I scroll out, Harry Street Business Service, 110 Leicester, okay. Mofo Burgers, that's funny. That's actually funny, hold on. I'm not gonna lie, that's actually funny. Okay, wait, do I know where this is? I feel like I do, man. Alright. Let me, wait, what is this? Law Building, Bouverie, Lincoln Square. This is far, man. The spot is here. We're gonna have to walk a bit, not gonna lie. Melbourne Connect. Alright, so you're telling me this is Lee Dow building. Damn, you're telling me this is where we're gonna be? One, 2, 2, 1, 2, 5. Build 1. 1, 2, 2. 1, 2, 3. 1, 2, 4. 1, 2, 5. It's a whole thing. Okay, well I know it's on the first floor at least. I know where to go to be honest. Mofo Burgers. Damn, bruh. Ain't too bad, not gonna lie. I would. Definitely. Definitively. Scroll in, scroll in. Hongli Dao building, of course, yes. Alright, good. Alright, so close that, let's close that. Close this. Alright, so start 11. Wait outside until your preparations are done. 1 hour, test format, contains multiple choice, short answer, and descriptive questions. Attempt all questions, answer all questions in the questions paper provided. Any unreadable answers will be considered wrong, no calculators. Please write your answers in pen. Everything that was covered in the lectures until week 4 inclusive and workshops until week 5 inclusive is examinable. Reading / study hints. Make sure that you revise assignment 1 assessment tasks. Please read the lecture slides and the corresponding section from the textbook. Make sure that you do the workshop questions. Use the discussions on the ed for your study. Okay. For sure. The question also becomes 1, 2, 3, 4. Yikes, no way. Toro week 4. I believe it should just be up to here. So no Diffie-Hellman and RSA. Okay, no Diffie-Hellman RSA. Wait, the tutorial week 5. Oh man, I gotta do that too. Nah. Okay. Let's try and speed through some of this then. Alright, so I'm happy with that. I would put this on another page, but I don't know. Okay, so install update. Diffie-Hellman. Look, Firefox doesn't look bad at all, you know? Damn, some of these pictures are so clean, I'm not gonna lie. Like, this is pretty clean. This is grainy a little bit. Alright, I like it. This is what I have on my other computer. I might like this, to be honest. I'll put it like this. Okay. So. Now that we have that solidified, put this back on this side. Okay. And what else? What else? What else? What else? Okay, I think I'm good to just study. The thing that I particularly need to study on is is something off here. Something feels off. No, I think we're fine. Some questions on quizzes. Why security attacks are classified as either passive or aggressive is false. Why the emphasis in dealing with active attacks is on prevention rather than detection. False. Why the answer for verifying that users are who they say they are, and that each input arriving at the system came from a trusted source is authenticity instead of integrity. I remember that in my tute it said that the authenticity is some subconcept under integrity. Why the answer of is the protection of transmitted data from passive attacks. Partially I can understand. Are there any types of encryption methods other than symmetric and asymmetric? Probably not, right? What can be categorized as non-conventional encryption? Is the principal security problem? Referring to Kirchhoff's principle. Is question 2, quiz 2, question 6 a statement? On average, half all possible keys must be tried. Brute force attack is true, but what if some technique is used to reduce the search space? Why the blank is substitution. Substitution techniques make plain text elements into ciphertext elements. Think any encryption method. It maps, right? For sure. Wang Hu. Oh my god. People have been going hard, man. Dang, bruh. Alright, we're gonna be kind of mad. Alright, I have to do some sort of study for that as well. Can't not, to be brutally honest. Okay. 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 I have to watch this though.
This material is made available to you by or on behalf of the University. Visit the University Copyright website.
You just think about, for example, we take mod 2 mod trivial, the 0 will have 0 0. So they will have a unique patterns, each pattern matching here, and that's what exactly. So if you have been given some residues mod 2,
I think this will be useful. Okay. Yeah, I have to do it anyway.
It may be subject to copyright. For more information, visit the University Copyright website.
You just think about, for example, you take mod 2 mod 3. So let's say mod 2 here, mod 3 here. So let's take any number, say 0 1 2 3 4 5.
What in the world are we talking about? CRT is the Chinese remainder theorem. You have x and y to be equal to a1 mod n1, a2 mod n2, n1. I'm guessing that means the GCD of n1 and n2 is 1. So the greatest common divisor of n1 and n2 is 1. So for example, mod 2 and mod 3, because these have the greatest common divisor of 1. So mod 2, mod 3.
So mod 2, mod 0, in this case it will be 0 0, that is trivial. Let's say 0 1, mod 2 also will be 1, mod 3 also will be 1. When you say mod, now for 2, mod 2 will be 0, but mod 3 will be 2. Mod 3 will be 0 in this case, but mod will be 1 again. Mod 4 will be 0, and here mod 3, when you take mod 3 for 4, it's actually 1, and mod 5 it is 2, then this you get 1 here. And you can see that if I take number of 0 1 2 3 4 5, the 6th number, the 0 will have 0 0. So they will have a unique patterns, each pattern matching here, and that's what exactly. So if you have been given some residues mod 2 and mod 3, I can always find an equivalent one. So if you really go through integers from 0 1 to n1
I'm kind of getting it.
and ask for look for those which are a1 mod n1, a2 mod n2, you will see a unique integer. That's always possible. So for a simple solutions, for example, I'm given say let's say 1 modulo 5 and say 2 modulo 7. Then I can actually find out all those numbers that match to 1 modulo 5, and they go like that. 1 modulo 5 will say 1 modulo 5 and 2 modulo 7 go like this. 1 modulo 1 is, that's true, and 6 also true, 11, 16, 21, 26, 30, 1, and of course 36, but it's already going beyond 35, you don't need to do it. Then say 2 modulo 7, say 2 here, and 9, then you have 14, 16. So you see, already I found a common number. So in some sense, what CRT is saying is not surprising. So you can always get, for a small number, you probably don't need to all of that. You just using this, you can do it. This also shows about the the equivalences that we mount as sets. Yeah. So this is basically a one-to-one or onto mapping. That is, if you have a sets of integer mod 2, mod n1 and mod n2, each of them actually uniquely map to integers modulo n1 times n2. So this idea is quite evident, and I think if you know this idea, you will be able to answer questions in the test time. That's not a big problem. But let's look at how do you remember this SCRT. So and I always try to give because if I can give a constructive way by using A1 and A2 and these parameters, then that would be useful. So for example, how do you actually create this mapping? So in the lecture notes, I have given clearly how to actually create this mapping, constructive mapping. But the mapping here is as far as very simple. What you can do is, say, let's say you have to remember N1 and N2. So just to for easy remembrance, you make capital N1 say to be the reciprocal of the this number modulo N1 times N2. So for example, you have N1 times N2 divided by N1. So basically, so this is N, right? That is N divided by N1, and so you can say capital N2 is N divided by N2. So if these are the two parameters, capital version of that variable would give you the, so because there are only two things in this, what is N1? It's N2, small N2. What is capital N2 here? Small N1, correct?
Damn.
Do you see the point? So this is pretty easy to remember. So you have these modulus are small.
Man, I
N1.
gotta remember this so
You find
much.
out first capital N. Then capital M1 is simply N1 inverse mod N1, and capital M2 will be N2 inverse modulo N2. Okay. So let's see, we do the same thing. Let's see.
Sure.
What is M1 here? Because in this particular application, N1 is 5, and what is capital N1?
N1,
So I have now N equal to
35.
35. So what is capital N1?
7.
7, very good. What is capital N2?
5.
5. So now M1 is 7 inverse modulo N1, which is 5. Now, see, when you are computing this, even it becomes very simple. There is no need to find 7 inverse because 7 is greater than 5. So this is same as 7 modulo 5 inverse modulo 5. Correct?
Yo.
So what is 7? 2 modulo 5 is 2. 2 inverse modulo 5. And M1 is equal to 3, correct?
I mean, I could figure that out from like
similarly,
just
let's say
thinking about
M2
it.
equal to, here equals 5 inverse into inverse modulo.
I suppose, yeah,
M2 which is 7.
that does make sense.
What is inverse of 7? What is inverse of 5? M2?
5, 6.
5 is here. So it's a small number, 7, right? So you can see 5 multiplied by
3.
10, that won't give you 1. 5 multiplied by 3 will 15, which is modulo 7 is 1, because 15 modulo 7 is 1, so M2 is 1.
Yes.
No.
No, 3. 3.
M2 is 3. Okay. So you know M1, M2, M3. So any general solution will be A1 times
A1 times
M1,
N1.
A2 times M2, N2. So you can say mod N. This is actually true is modulo N.
And this is the Chinese remainder theorem.
A1 in this case, in our case, we have been given as 1.
1.
M1 is 3. Capital N1 is 7. Plus A2 is 2. Capital M2 is 3. And capital N2 is N1, which is 5.
Mod
Mod
35.
Even in this case, N1 is actually small n2, right?
Okay.
And N2 is capitally small n1. So if I take mod n1 to this equation, what will happen?
Mod N1.
Mod n1 equation, this will become 0, and this will become, M1 is actually N1
Mod,
inverse.
I see.
So, but and you get back A1. That is the first equation. But if you take mod n1, then mod n1, so mod n2, then this becomes 0, and this is 1, and then you get back a2. So this solution is actually constructed from that way.
I see.
So in this case, let us say what we
Wait.
do. So it says this is 21
Yeah,
times
please.
1. This is 15 times 2, 30,
Sure.
mod 35. So you can see that this is basically 51 mod 35.
Sure.
And of course, you got a number beyond 35, so you had to take modulo 35. And how much you get? It's exactly the 16.
16.
So that's it.
Oh,
So, but there is a one unique number before 35. This is a CRT. Okay.
Mad.
If you can do the equations
Mad.
like this for on small number of other equations, like check
Mad.
n1 to be 21, n2 to be 23, and in a small numbers, then you will become pretty
Efficient.
efficient, able to compute this. Correct?
Yeah.
So this is about the CRT. So we cleared it. Other day we made a mistake. So what I'm saying is that in it's always possible to make a mistake. Mistakes are humans, it's quite natural. And sometimes, I will be knowing CRT, and but still after some time, then I can mess up with, M1, M2 will become M1.
Don't worry, don't worry.
So that's why when you are writing down equation, have some
It's okay.
policy that you go through with the same order. So whatever the algorithms you do with the same order, like whatever you learned, and so you won't make any mistake. Only, that's kind of consistently you have to go with the same, especially for the, like I remember, I think I showed you, maybe. Oh, I may have it here. Let's see. Remember the other day, I went through calculation for finding the GCD between numbers. We went through this. We went through in the class. So you can see when you are first you do this one, you take a quotient and a remainder. So whenever you're representing that as a remainder equation, you make sure that always you write the quotient next to the value that you are dividing. So this is a quotient, this is a remainder. So always you make this particular order. You become consistent in representing this order. That will help you to not to make most mistakes. See, even if you write 1 times 19 plus 8, that the equation is correct. But here you can have, for example, when you divide here, for example, what is this? You got m.
How do I do it?
Divided by n. You got a quotient, and you got a remainder here. So basically, you do when you divide this, n, you do m, and you get a quotient plus remainder. If you keep this order, then the moment it becomes 0, then the previous step remainder will become 1. So now I can represent 1 as use this equation 3 minus 2.1, and then this 2 has come here, so you can replace that 2 with the previous equation 8 minus 3 minus 2. Then then you all the simplifications also you follow in a consistent manner. Then you will not go wrong. Okay. Now in the workshops also you would have taught something, and these also tables are available, and any particular technique that you learned, you do it, but stick to it and don't intermingle with that. Okay. So that way that will help you to do it.
I agree.
And then the main idea was that we are able to express GCD as linear combination of its input, and whenever you are taking a modulo one of them, of course one of them will become 0, then I get an equation for inverse, and that's why I found the inverse. So the inverse equation that we discussed, that's become very important. At least now inverse concept is very clear. So please go through the modulo n and inverse, those ideas. Then just how did you compute about inverse of a Euler-Totem function of when n is a prime number. Phi of n is always 1 less than that. That's clear because there is a prime number. And you also just go through, I did a lot of that, for example, how do you prove that
Euclid's algorithm.
there are infinitely many prime numbers. Okay. Now,
You can't use Euclid's algorithm.
The algorithm that we do is if
sorry.
Let's say you start finding, there is always an algorithm called Eratosthenes sieve of Eratosthenes. So one of the old mathematicians. Let's say you want to find a number 1. So leave it 1, 2 is the first prime. Then moment you have 2, all multiples of it you remove that from 2, 4, 6, 8 from the set of rooms. Then you go to 3, you remove 3, 6, 9, all other things from the set of primes. So as and when you find a new prime, I can start recording it, P1, P2, and I can count them. So each, because there's always possible, in this particular process, you will always find some which is not cancelled by the previous primes. Hence, there will always be a new one. So that if you are convinced with that, then there is already infinite prime. If not, there is a particular way of proving that there are infinitely primes. Because assume that you already know primes up to P1, P2, P3 up to Pn, the nth prime, and I don't know nth one prime. But now I construct a new number which is Q, which is a multiplication of all those numbers plus 1, and I claim that to be a new prime. If that is a new prime, you already found a prime which is bigger than all of that, because remember this number is a product of all of this plus 1, so it has to be bigger than each and individual of this prime. So the new prime Q is definitely bigger than that. So I found another one. So with this, if that is a prime, then I'm done, because I always find another new one. But you may say, oh no, this may be a big number, but this may not be a prime. Oh good, if it is not a prime number, then it has to have a factors, and one of them should be let's consider Q1 to be a largest factor of that, and the others one C as something. What we can prove that each one of these is actually less than this largest factor of it, and hence so this Q1 is always greater than Pi for I equal to 1 to 1. Then also I found another number, prime number, which is bigger than that. So this number, either this is a prime or it has a large prime factor bigger than this. So whether can this help to find all the primes? This is a one simple idea, proof. This is a mathematical proof, but this doesn't still tell you. Actually, this doesn't tell you what is the next prime. Okay, I have gone up to that point. What is the next prime? That will not tell you. It will tell you there exists one prime bigger than this, and hence I'm convinced that there are infinite primes, no problem. But it doesn't tell you the next prime, right? Yeah? So if you can come up with an algorithm, efficient algorithm to come up to this point, I want a next prime very precisely, and I should be able to compute it in a time which is polynomial with the primes I have. Then that, if such an algorithm, if you find, it will be an important progress in prime number theory. Nobody knows exactly next one. Okay. Yeah, I can know some. Do you see the problem? So sometimes some of these ideas are sometimes you may have a proof you almost there, but at some point of I'm still there. That's the kind of. So this is the kind of. This is called mathematician way of proving things which are not acceptable to computer scientists. We want, if you want to say a new problem, I have to give you an algorithm to do that. Of course, I can give you a very randomized algorithm, I can always find a new number and all those kind of things. There are so many such problems are there, but we still don't know what is the next one. But of course, for us up to 1000 or 2000 primes, I can do it faster because we already have other memory. But the idea is that in order to be able to give it for infinitely many, and what's the next prime could be? Can you think? Let's say you go 1, 2, 3, 5 is next prime, then 7, then see 8, 9, 10, there is a gap of 3, then 11 is a prime number, but 12, 13 is a prime number. So see, in the previous time I had a gap of 3 numbers, but 13 prime came just one after that. 11, 12, 13. Then 14, 15, 16. After 3 I got 17. 3 gap, 17 prime number. Then 17, after 17, 18, no prime number, 19. So you can see 17 and 19. So you see, sometimes the distance between 2 prime numbers can be just 2. Just with 2 I get a prime number. Okay, so why I'm saying that finding the next prime number is still not known, because this set of primes which are prime number and plus 2 another prime number, they are called as twin primes, even though they are not neighbor, but they are twins, right? How many such twin primes are there?
Damn, bro.
Now there is a conjecture saying that there is infinitely many.
Infinitely
So
many
go
twin primes.
there's infinitely many twin primes. Can you find that one? So which are those ones? So I find now 13 and 11 is a prime number. Next itself I got 17 and 19. When will I get the next twin prime number? There's the next question. So you can ask, if you don't know one question, we can ask many questions which you can't, from there I can derive. So computer scientists are very good in actually creating this. So if you know this solution, I can solve this solution. Or if you don't know the solution, I can give you another problem which is even more difficult for you. So these kind of things, lots of problems are there. Anyway, they are not required for our RSA.
Yeah,
but they are for
doesn't even need to bring it up.
we did. What else you want to know? Also, probably then what I did was, week 2, week 3, week 4, additional. Okay, so some of these questions which were there. Yeah, so some of these things, simplifications, can you all do easily? So we have also give the solution last week, but what is 64 mod 10? 4. So in this case, the idea of that problem is, because it's a decimal number, if you are looking for modulo 100, for example, you just take the first 2 digits, that will become the solution. The reason for that, you can express 64 as 6 times 10 plus 4 times 1. 6 times 10 will become 0, you can do. So by having that one. But what about the next one, modulo of C? C? How much? 2 to the power of 145, 3, 7, modulo 4. Huh? 2? Now, just think about it. Say it's a modulo 4, right? When you have 2 to the power of 145, 2 to the power of 145. 2 square itself is 4. 2 cube is 8. 2 to the power of 4 is 16. So when you have 2 to the power of 145, there are so many 2's in it. And definitely 145 is greater than or equal to 2.
Gonna have to look at this closely.
So hence modulo 4 will be 0. Because if one of them is 0, 0 times 0 is 0. Okay, that's one simple trick. Also, when you such question,
Oh. Mod 4 is 2, right? No? 2 times 2 is 4. Mod 4 is 0. 0 times 0. Ooh, it's just going to be 0.
when you are thinking about 9 to the power of 777, what is that? Modulo 4. 9 to the power of 777, modulo 4. Just the last bit, last expression. It will be 1 because, whatever may be the big number, you don't need to do it. First you do 9 modulo 4 is 1. 9 itself is 1. Then 1 you multiply by many times, you get 1. So that's why I know whatever thing as time progresses, human beings should at least accumulate knowledge in an additive manner. If you accumulate in a multiplicative manner, you will not grow at all. 1 multiplied by many times is 1 only. So even just to grow a little bit as a human being, you need a little more. Small is thing. Huh?
But it's actually because the number is odd or even.
Yeah, correct.
It's odd, like.
I mean, you can simplify. The main idea is to see whether you can simplify with those equations. I mean, not always you will be able to get the answers quickly, but at least the base numbers you can take modulo and reduce it, and then come up with some other rules to eliminate and do it, not actually computing it. Yeah. So this is what happened to Gauss. You remember his teacher gave an example. So he thought he wanted to take a rest, and he said, all kids now today you multiply numbers from 1 to 100. Okay. And he thought that they will take a long time. Gauss immediately come and said, what is the number? If you multiply by 1, 2, 3 up to 100. 50. So basically 1 plus 2, 3 up to n is n times n plus 1 by 2. Okay? So you don't need to really, so if there is some problems which has some lot of structure in it, you really don't compute it, right? But if otherwise you may have to compute it. If I give you some special numbers, then we'll come to the computation problems. We have lots of such problems in computer science, okay? But some of these things are you can do. So I have. So that's why I think you can actually apply these identities. So if you want to add two numbers modulo m, then sometimes x can be anything. But first you reduce it modulo m, then reduce it modulo y also modulo m. So when you add it, it only grow by 1 bit. And then taking another mod m, you'll get the answer. So similarly multiplication. If you multiply by x mod m and y mod m, if you multiply, you get x phi, which is it becomes double the size, and then it takes more effort. But if you take modulo m and modulo m, then answers can be done pretty quickly. So some of these things, and I also gave you the efficient exponentiation algorithm last time. I think that one you all probably know from your complexity lectures classes, that finding an efficient algorithm for exponentiation modulo. Is that clear? exponential modulo, everybody can do it in linear in the number of bits representing the number. So that's faster. So, and that's another question. Let's go through here. So for example, here, if I want to compute x to the power of 5 mod 10, x can be any integer. One way to simply do it, first you compute the solutions for x to up to 10, then after that, I can use that table to write answer for any number. First you take x to 5 and then that will be very easy, right? So these kind of things, and then we also had some finding some expressions for primes and prime factors. I think you probably all know this. Yeah. Is that clear? Some of this kind of you can simplify. Then you can also simplify using Euler's theorem, and you know, and so we have given you some results of that nature as well.
All right. Well, damn. I gotta eat now. I'll be right back.
Okay, this is a thing that, so I covered both. And then I go back here. Let me just go here. Another thing that I want to do. So this is the idea that I wanted to clear. So these are some of the additional reading for week 3 that you may have to read. You will have to read yourself. So for the test also it's better to, so in the other day lecture I covered first aspect of it. So these are called the modes of encryption, modes of operation. So they are for, so understanding all these 5 different modes and why they are there. And this actually is really applied cryptography if you actually follow, you know. So let's come back to the main table a little later. I think I covered the this is working as a codebook mode, that is electronic codebook mode, which means that this is it's very clear from the context, it's a block cipher, right? In this, you have got different blocks of plain text, P1, P2. With the electronic codebook mode means that each time, so you use the same key, but same key is applied for the encryption box, and you get a corresponding ciphertext. And the decryption is simply same. There is no connection between one block to another. Independently, you treat every block independently, encrypt it. Okay, that's the ECB mode. Now this has some consequences. For example, when you have, let us say, a plain text which repeats, maybe when you like a file or a multimedia. So if you take every 64-bit block, and it's quite possible that some blocks will repeat. So if some blocks will repeat, so P1 is equal to P2, then with this mode, C1 will be exactly equal to C2. So whether somebody can decrypt or not, let's say the adversary who is watching this communication, he can immediately conclude that these two are same plain text. Clear? So that's why when you have a lot of data to be encrypted, you don't use it in electronic codebook mode, because you give away this kind of information to the adversaries. So typically, then what for this mode is there? So we may have, in many cases, for example, you may have a small PIN number, passwords. If you want to encrypt it, then it's the messages won't go beyond one block, and some for such things you can use codebook mode. Okay. So that's why, and you can go back now, understand. So studying this one is pretty straightforward, and sometimes you don't need to go through everything, but just by using these figures and the corresponding explanations, you will be able to understand. So for example, here, this is, what is that? This codebook mode, and it talks about here. So all the explanations are there, and you can read, so, and about the security aspects and other things are there. ECB also I discussed the other day. Let's go back to another mode. Say for example, let's go to even not this. Let's go to the next one. Let's go to the counter mode, which is the simplest mode. So in the counter mode, how the encryption encryption takes place, how the decryption takes place, you can observe from this schematic diagram itself. So for example, here I have a counter. That counter runs independently. Like counter, it starts with 1, 2, 3, it goes, you know. So, or it could go to in pseudo random way. You can have some
Convert a block cipher to a stream cipher. Cipher feedback, output feedback, counter mode. Cipher feedback, counter feedback. So there's CBC, there's ECB. Is there anything else to CBC? No, it's just encrypting. It's like the simplest of the simplest. And ECB. This is what? CFM, CF, CFP, OFB, CTR. CFP, OFB, CTR. CFP,
register and make them go.
so this is cipher feedback. Encrypt with initialization vector. You encrypt the initialization vector. Discard B minus X bit. Select S bit. Where S bits and the plaintext become XORed to the ciphertext. Then you shift the register. Shift the register B minus S or S bits. So that's your new initialization vector. I don't know what or S bits is. but it continues this way. And then decryption is the same thing. Oh, this looks weird. Still goes forward. Still goes forward, but instead of the plain text, you XOR it with the ciphertext of 1 to get the plain text. Text of 1 to get the plain text. I mean, I get that, yeah. Cipher feedback mode. Alright, and then output feedback. So it's basically the output of the encryption function goes in as input. The instead of cipher feedback, you got output feedback. But why doesn't the output feedback need selecting? And then there's counter.
One after another, and it will span the whole space on which the register is defined. So the counter can be just like that, okay? It need not be just 1, 2, 3, but it can be any pseudo-random function that goes on changing from one time to another. And eventually they overlap. You know, like counter means at some point of time you come back and join.
Alright, I'm back anyway. Whoops. Let's see.
To the previous one. Now let's say one of the features is that how the encryption done is, you have a counter. Each time you have a new plain text block coming, I'm going to encrypt with a sequence of ciphertext obtained by encrypting counter. So you just basically use the counter and give the key as the same key, and that will be XORed with the plain. And next time is the next counter, and so forth. So you can see in this case, irrespective of whether what is the plain text, the streams can be easily computed independently. For example, if you are writing some engineering application where you are expecting some blocks of messages coming into the encryptor, and I want to speed up the communication, speed up the encryption. What I can do is I can pre-compute with the key, starting with the key, all the ciphers ready, depending on the buffer, and as and when come, you can just XOR it and send it. So because of that process, what is the decryption function? Decryption function has to be, exactly repeating the same thing that what was done in the transmitter. So both of them have key and they have the same counter. So the C1 is basically the you can see that C1 is simply the XOR of the cipher obtained here. And now when you repeat that in the decryption in the stream cipher mode, you basically you get back the plain text. So this is just like equivalent to one-time pad that we studied in the kind of things, because now say one key that generates with a stream of blocks, the stream cipher blocks. So this is also considered as stream cipher mode. And in fact, out of all the modes of thing, the later ones are all stream cipher mode. And you can see that's why both the encryption and decryption, only encrypt of a block cipher is used in this encryption here. This is the encryption of a stream of bits, but we have made the only encrypt function. Do you see the point? Whereas in the CBC mode, with the way it was encrypted, I need both encryption and decryption of the underlying block cipher. So you should not get confused here. Encryption and decryption happens to the plain text media here, because the different modes of things, right? So I got the encryption operation in this mode, decryption operation in this mode. These two big operations will involve encrypt or decrypt function of the underlying block cipher. In stream cipher mode,
What am I listening to?
Do you get this information, this idea? Okay? As opposed to this, let's go back. So if you are, I want to actually, as opposed to this, let's go back to this mode. This mode is a CBC mode.
CBC, yeah.
What we are doing is the encryption is performed on the input stream of blocks. The input stream of blocks are coming P1, P2, P3 like that, but it was always encrypted using initially some IV initial vector using the same key. Then the ciphertext block is fed into the next stage of block cipher. Then it is fed into the next cipher. But because of the way it is done now, the decryption for this particular mode of encryption has to use decrypt function of the underlying block cipher. Did you see the point? So this is after reading this chapter 3, and if you can't make a difference between these two aspects, that's not good, right? This is what I'm telling. So using common sense, you can actually get it. So same way, even the electronic code book mode, when I encrypt with a particular block, you need a decrypt function of the underlying block ciphers. So now with this explanation, let's come back to the what we have here. So you can see that electronic codebook mode and cipher blockchain mode, these two things both encrypt and decrypt of the underlying block cipher. Whereas the cipher feedback, output feedback, and counter, these three doesn't require some decrypt function of the underlying block cipher at all. Because the way these are done, they are also used is called stream-oriented communication. So you can see general purpose stream-oriented communication, output feedback, stream-oriented transmission over noisy channel, CTR, general purpose block-oriented stream communication. Yes, so last three modes are for stream using block cipher as a stream cipher, whereas the first two ones are a truly block cipher. That's because the underlying block cipher uses both encrypt and decrypt. Yeah, correct? Do you see the distinction? And this is what you need to study if you are, So using this one, you can easily make such things. Then there are certain other things which you need to worry about. Like you can see the counter mode, OFB mode, and CFB mode. These are all stream oriented, and the first two ones are block oriented communication. And then certain things. Why authentication only given for CBC? The way in which this mode actually enables authentication naturally, and that's what the next point that you need to check and understand. Okay, clear? So this is that's why I think there's no point in. Giving lectures on it, unless you study because this information. So we studied block cipher, how block ciphers are constructed, or at least we know the general principles behind in coming up with it, and then we show that okay, we have DES and AES, and these are general principles. I mean, there are lots of research has gone into actually making them. We don't go deep into the mathematical theory part of that, right? But after having obtained one such standard, I'm now going to use this in real life communication, and I will face with a lot of security challenges. And these modes of encryption has been devised carefully to address such situation. So sometimes cryptanalysis thing, they will not necessarily go into the attacking the actual algorithm, but they will look at any fallacy, any vulnerabilities that exist in the way it is being used, and that will help them to attack the keys. So this is I think and of course there are some with the cipher feedback. There is also variability. I can check yes from 1 to 6. I can vary. So you've been given a lot of freedom in redesigning your thing. So even though you have one block cipher, I mean these blocks of cipher came along with the DES. But now DES is not a cipher at all, right? It's not a part of the standard. Now we have AES. So whatever may be the block cipher, this mode of encryption is useful. So hence, this is a very nice. I mean, why I'm stressing this? Because when I'm going with the next week hash functions, we will revisit some of these ideas to create hash functions. So, you know, from last 25 years of cryptographic research is full of analysis of some of these basic ideas. You know, when you construct the hash functions, you use structures something similar to this. When you construct the MAC function, you use structures similar to this. So understanding some of these are you know, very important, and you know, that will also help you. So when you become a crypto engineer, if you know the design principles behind this, then it will be easy to react in it. See, that's what I'm saying. So when you are learning, what are the different aspects of the learning you as a master or a bachelor student? In some cases, you learn something and you want an answer to certain thing. But then now there are a lot of ways you can get the answer. You can go to a web, you can Google, search it, you can get I can ask if you are other thing. Oh, do you know how to do it? You can ask and learn something. Okay, and then you learn how to present it. For that, you need to know very good communication skills, and these are the things which you will be learned, you know, as a part of, you know, when you write a report, it has to be authentic. You see, because you can't just simply ask someone else to do it for you. So you have to do it yourself. So doing it yourself is because whatever the assessment has done, when a marker marks it, that's what you earn it. So to earn it, you have to show that you understand every aspect of it, right? So let's say in kind of learning now, in this case, what are the different aspects that you learn? So you learn, for example, oh, so these are the mechanisms in handling with different aspects, you know, like when the communication is block-oriented thing. And then, so you have to think twice, which one is better for this, for a block-oriented communication, this mode may be better, right? And you can ask a question, and some AI system might give you the answer, but this importance of learning that let's say now you learn that particular idea, that with that idea you can even verify if let us say some dumb machine gives answer, this may not be correct. So this type of knowledge acquiring becomes very important. That is what you learn when you come to the university. You will not get this opportunity when you go to the other place. Of course, you can learn. It's a lifelong learner. We can also teach you how to learn, but learning is important, and some of that aspect is focused in this subject, where you pick up that knowledge. For example, how to do XGCD algorithm, how to do RSA algorithm. So if you learn that, then after that nobody can take away that knowledge from you, right? So this is the thing that I'm stressing. So that's why we want to know how you are learning now this subject, and the MST will address that. Okay, and there is no hurdle in it. So you should face it with confidence and really check whether what you know are correct. Good. Good. So I'm not going to give you the MST questions now, but you know, I've given you the general algorithm to face any test. I think these are the two things that I wanted to take. And remember, I also talked many other things during the lecture things, like for example, so for example here you see how to do the exponential modulo things we discussed in the lecture, this method, right? So you can multiply, keep on multiplying with this. It's a dumb way of doing it, but instead of that, is if you want to a to the power of n, you can do multiply n times. This will be exponential thing, and to realize that that's the exponential thing is the knowledge. That's what you agree. But I can do it by a very simple algorithm. So for example, I want to take a power. So this particular solution is done by just one multiplication if I had known how to take a g to the power 36 and a g. Because if this is an odd number, I'm going to reduce that problem. So when I see something odd number sitting in the exponent, let me reduce this first. Let me make that idea simple. So okay, g power 37 is same as g times g power 36. That's clear. I have now applied a general idea, and then once I do that, but still it's a big number. But because it's an even number, I'll do what I do. I can now divide by 2. That means now reduce the number half, g power 18. So if I know some g power 18, finding g power 36 is simply taking 1 square. So that means you remember almost 18 different multiplications are done just with one operation you finished it. And you repeat this until you get all the things. So this is the kind of square and multiply algorithm. So if you, yeah, clear? So this is the idea, and this is what you taught. This was taught to you in algorithms and complexity class, and we can, so you can clearly prove that the complexity class this is about order of n, order of b, where b is the number of bits to represent the numbers, as opposed to order of 2 to the power of b, which you can try on some of the tools that we have given, Magma and Mathematica and others. Try to do exponentiation without taking the dividend, square and mod. Answer even for a modest number of 10 bits, 100-bit number, it will take hours. It will not. You won't get an answer. But if you do with modulo b, you get answer quickly. So this is the kind of computer science in action. So these are the good ideas, which we do, and I also gave you, for example, how to give the idea of a Diffie-Hellman key exchange protocol. That means two users who have not met before, they're able to obtain a common secret only known to themselves. And I showed you how this is secure. That is because Diffie-Hellman, with the Diffie-Hellman protocol, came with problem, computational Diffie-Hellman problem. That means the parameters that exchange in the Diffie-Hellman problem, that becomes computational Diffie-Hellman problem. Again, this is the funny part of cryptographic research, where you throw a problem and you can write a paper. Okay, so whereas in other places where you say you solve a problem and you write a paper, whereas of course you can also solve a problem, but this problem, computation Diffie-Hellman problem, there's no problem, no solution. So you can see, because that's a hard, but if you know the discrete logarithm problem, then I can solve the computation Diffie-Hellman problem. Okay, so that I can show that very clearly, right? But if you know computation Diffie-Hellman problem, can you solve discrete logarithm problem? This answer is not known yet. This is also another open problem. So cryptography is fraught with a lot of open problems and a lot of interesting problems. Sometimes which aspect you have made use of in your algorithm is something, the knowledge itself. Yeah, that's to be learned. Yeah. Yeah. So I think, yeah, so that should be it for, I think I have covered most of the things required. So next week I will go with hash function. So Tuesday there won't be any lecture. You will come to the, what is that, Coley, on a Queensbury Street. That's the place where the MSc is running. And please come before the time, and we need some time to set up the examination hall, and you get about an hour to solve one 5 minutes of 5 minutes reading time, and then the rest of the things you can prepare. Okay, see you tomorrow. See you next week for the test, and then on Wednesday here I will start with the interesting topic of hash function.
Hash functions.
See you.
Hash functions.
fine, but yeah, so that will be easy to do that, yeah.
It should be the mode equal to 1 rather than 9.
The mod is 10.
All right. Let's just do these. Okay, one of the useful features of the Chinese remainder theorem is that it provides a way to manipulate potentially very large numbers mod m in terms of tuples of smaller numbers. Tuples of smaller numbers. I'm going to say, I can't imagine the tuple, but smaller numbers, yes. An important requirement in a number of cryptographic algorithms is the ability to choose a large prime number. Yes. So asymmetric encryption utilizes a public key for both encryption and decryption. True. Oh wait, encryption. Only. So an asymmetric encryption can be used for confidentiality but not for authentication. Does that make sense to me? Asymmetric encryption can be used for confidentiality, but not for authentication. I think that's false. I think it can be used for authentication. Let me double think. What does it mean to authenticate? It should, because passkeys are literally made up of. So I'm saying that that's true. The number 641 is a prime. So therefore, all the positive integers from 1 to 640 are relatively. Okay, wait, hold on, there's a really loud noise. Okay, so the number 641 is a prime. So all positive integers from 1 to 640 are relatively prime to 641. That's true. That's basic understanding. So public key encryption is more secure from cryptanalysis than symmetric encryption. Is more secure from cryptanalysis than symmetric encryption? Yes, I think so. You know, because it depends on what symmetric encryption you're using, but in general, you know, all symmetric encryptions, cryptanalysis of public key encryption is not possible, or not doable very easily. The public key encryption scheme is not vulnerable to a brute force attack. It is, but it isn't. It isn't because of I mean, this is an iffy question anyway. So a something number can only be divisible by plus or minus values of itself and 1, and it cannot have a remainder. Well, it's prime, right? Ooh, I don't know what a composite is, to be honest. An important quantity in number theory referred to as